Welcome, and we are going to dive into section 1.5 from the textbook, which is linear equations all over again, but this time we're going to focus on more of the applications and the modeling end of linear functions. So really all we want to be able to do is still create a linear function, but more so focus on that modeling aspect. Okay, so you can see all the different learning steps in the videos here, and so here we're just going to begin with an example. Okay, so we know we have this information about a line and we want to represent it in as many ways as possible. Well, you might remember we had similar exercises in the last section, right? So we may want to start out by finding the slope, and so we do that and we end up with minus 1 minus 4 over 2 minus 3, and so then we get a negative 5 over 5, which is minus 1, and then so we can get our first representation of a line, or at least I start with point slope. So I would do y minus 4 is equal to negative 1 parentheses x plus 3. It'd be a minus 3. Okay, and so this is one representation. Now this is the textbook actually formally includes this in section 1.5. We introduced it earlier, but so you'll see that on homework this time. Anyway, continuing, if you want to represent it in as many ways as possible, you can add 4 and simplify, and I'm going to omit the work, but you end up with y is equal to minus x plus 1, and then so that's your second form of a line, and then your third form would just be to make sure that the variables are on one side and call that standard form. So that'd be x plus y is equal to 1, and there we go. And you'd have to make sure it's integers. Okay, so we have all the algebraic representations. We could look at it on a graph, which once we do the algebra, it's a little easier to make the graph. We could also, before we do the graph, we could look at a table, right? So we could do x, y, and then, so for example, if x is 0, y would be 1, and then if x is, I don't know, let's just do 1, then we get 0. Oh, that happens to be pretty nice. So then, just putting these quickly on our graph, we have those 2 points, and bada bing, bada boom, there's our line. Okay, and then certainly we could talk about the graph or the descriptive form. Various ways to describe it. You could just say, like in words, y is equal to negative x plus 1. Like you could say that. I just happen to say this to incorporate the interpretation of the slope. So I would say, starting at minus 3, 4. For every 1 unit increase in x, there is a negative 1 unit increase in y. And that's all I would do. You could also say there is a 1 unit decrease in y. That's fine too. Okay, so again, this is kind of old hat. We did this in the last set of videos, and so why are we doing this again? Well, you might remember again that population problem back from chapter 1 in section 3. We had this modeling problem, and we wanted to construct a linear function that would model that context. And so if you want to, hop back to video 1.4-1 where we first introduced linear functions, and we did that there. We just happened to use y and x, and so you could continue to use that model that we generated there to answer additional questions about the scenario. Okay, so that's kind of the premise that we're going to work in. We're still working with linear functions, as you can see, in all their various representations. We are just going to now focus more on the contexts.